all the way down to here. But I can, yeah, so this part. Okay, sure. Let's start with question number 7. So this question is quite tricky. And first, a simple question. What do you think is the price for the Netflix here? And would, yeah, any thoughts? It's 15?
Monthly.
Yeah. 15 monthly subscription, right? That's just the fixed cost.
Yeah.
Which means you have always to pay that part on that. Okay, and without the other part, we call it either variable cost or opportunity cost. I know this might be this. You may find this question in number B. Yeah, actually in number B, but I think this is quite important. So here, the opportunity cost for consuming 1 unit of Netflix is what you lose, right? The opportunity, what you lose through this, and actually you are losing your salary or your income because you are watching Netflix instead of working. And what all discussion is on a daily basis. So what do I mean by daily basis here? I mean, for 1 unit, it is not here it is 1 hour, okay? The unit is hour. That's why it's on a daily basis. We all analyze on a daily basis. And if it goes to monthly, it's quite strange. And I think professor should have stated clearly this income the I equals to, I write this down here. I equals to 24 minus 8 minus NF times 20. This the budget constraint, the budget constraint. Sorry, it's not budget constraint. So the income function. This income function is based on daily basis. It's 24 hours. So that's the maximum hours you have in a day, and the 8 hours is you use to sleep, right? And this, if you subtract 8 by 24, you will get 16. I will write this down like this. I equals to 16 minus NF times 20. And your income cannot go negative, which means your consumption of Netflix cannot go above or go greater than 16. So Netflix should always smaller than 16.
Yeah.
Sure? Okay, so that's part of the question A, where they ask you consider consider the maximum level of Netflix allowable by the combination of 1 and 3. And this is a limit, a restriction to before we start our analysis here. And you may find it when we go deeper, and you may find this number may not be correct since we got some fixed cost, which means our total income, the maximum income, may be shrinked, or maybe may not be that big because of the fixed cost. But for question A, 16 is okay. Okay, and let's start with question A. They ask you to combine 3 constraint questions into a single constraint equation. So that's this equation. If we just try to do a little bit algebra, it will be I equals to 20 to the 320 subtract 20 times NF. That's I. That's from the equation 3. That's from equation 3. This thing. And if you replace I in equation 2 with this I, you will get your budget constraint. Hopefully, you will get your budget constraint. Let's do this and see what's happening here. The PNF, when conditionally on Netflix is greater than 0, plus AOG is always smaller than your income, which is this. Okay. So here it does not mean, in my previous office hour, I told some of you that here it means PF times NF. That's not true. It's just the price of Netflix. And this bracket means conditionally on Netflix is greater than 0, which means you consume Netflix. If you do not consume Netflix, you will not face the fixed cost of the Netflix. You won't spend the 15 monthly subscription because you don't consume even 1 single unit. So this only happens when Netflix is greater than 0. And the AOG is plus AOG. This is a unit. This is a unit of all other goods, and it's smaller than 320 subtract by 20 NF. And if you put this NF, if you move this to this side, which means you add both sides by 20 NF, you will end up with this equation: PNF conditionally on NF greater than 0 plus 20 NF plus AOG is smaller than 320. And you can replace this with like the equation, like equal. So it's a very typical budget constraint. The only difference here is you got this part. This part is only something different from the very traditional one, because in traditional one you got like the price of Netflix, you got the price of AOG, which is 1. You got the quantity of Netflix, you got the quantity of AOG, and you got like the total income you can have. But the problem is you got this, this small thing, this tiny thing here. It can be very small, as the PNF is only 0.5 for a day. It's only 0.5 for a day. But you have to take that into consideration, which means if we set if we set AOG to 0, if we consume 0 AOG, what will we have? If we consume 0 AOG, we have PNF greater than 0 plus 20 NF is smaller than 320. And this, if we do consume some Netflix, this will be 0.5. So we can subtract both sides by, this whole part will be 0.5. So subtract both sides by 0.5, we got 20. Netflix is smaller than 319.5. And you divide 319.5 by 20, you got like the maximum Netflix you can consume, which does not make any sense because we are discussing in hours, and here is not an integer. But I'm not sure. You can write this on. You can also write this number. You better write this number also in your answer key. In your solutions. So yeah, I'm not sure whether Eric will take it as a 16 or this. I prefer 16 as a as a limit, as the answers to the second question to A. When professor asks about the maximum level of Netflix, okay, and you may use this number. And the budget constraint is here. This is the budget constraint. Or you can just do a little bit algebra and make it look like this. Look like this. Here will be like the
equation.
Yeah, exactly. The budget constraint. And this will be like the maximum. And you can also answer 16. 16 is also, it's more obvious. It cannot be greater than 16 because all the other hours you have spent, all the other 8 hours you have spent. Even though you stay at home and watching Netflix all day, you can only watch 16.
Why did we multiply it by
20?
20, yeah.
Yeah, right. The 20 here is like from this equation. From this one. This one, the I is multiplied by 20. I just do the algebra. I just, I just do algebra. I see. Intuitively, why are we multiplying by 20? I think my explanation is the opportunity cost, like the price of watching Netflix, is like the price of leisure. You can think it as the price of leisure. Netflix is kind of leisure. The price of leisure is your salary, is your wage, and $20 will be your wage. Which means you can see this function. If Netflix equals to 0, what if we set Netflix to 0? Then income equals to 320, which means your daily income is $320. And 1 additional hours you spend on Netflix, you will reduce your income. Your income will reduce by $20. 1 hour by 20. 1 hour by 20. And it's a very I think this is a typical question for income and leisure, for like the relationship between your income and the hours you will spend on leisure. And the price for leisure, remember this, price for leisure, P leisure, equals to your salary or your wage. Of course, you have to match that to the time reference, to the time period, which hourly or weekly.
So salary wage is the opportunity cost.
Yeah, it's the opportunity cost. You understand? Yeah, I think you got it. since we are talking about leisure as a good, here it's the hardest part. Is we are thinking of leisure, like the playing or something, anything, or maybe watching Netflix as a good, as a certain good, as a real good. And then we have to talk about the price. And the price for that is the price you pay for 1 hour of leisure is your salary, because you're losing that salary. For here, you understand this as good. If you don't understand, just follow this. Just expand this and plug this into this part, and you will get the answer. And then we can forget this. We can just do a very typical question with like the budget constraint, the utility function, and to solve the optimum model. Mm-hmm. So that's part A. Yeah, and if you miss this part, you can check my video. So I'm going to directly read everything. You can check the video. I hope it's still working. Let me check. Yeah, it's still working. Okay. So for the second part, part B, give a definition of opportunity cost in one sentence. So you have to give the definition of opportunity cost. So what's that? Opportunity cost is like the price or the wealth you lose for doing something. It's the opportunity cost. It's everything you lose for doing something. Like the opportunity cost for getting a master degree is everything you lose by getting a master degree. It's opportunity cost. You lose like your time to play. You lose your like the wage maybe as a blue collar worker, right? And you lose like your time to account your family. And here, if we put this into this situation, the opportunity cost for watching an additional hour of Netflix is your salary for the hour, and that's all, because that's all you can derive from that hour. Like the salary, you can get $20 from the hour. Which term in your consolidated constraint equation reflects the opportunity cost of watching an additional like the hour of Netflix? So I just put the budget constraint here since it's very important. It's a 0.5, which is a PNX, conditional on NF is greater than 0, plus 20 Netflix, plus AOG, which is 1 times AOG. Okay, there's a 1, equals to 330. Actually, it's smaller than, it's no greater than, but I replace with 0, okay? Since if a budget constraint function is written as this, it's not indicating only this line, it's indicating all the areas. All the points in this area can satisfy the condition, it's smaller than this. But if the budget constraint is written as a equation, as this, then it's just this line, But we are just analyzing all the points on this line, since all the points on this line can satisfy this equation. Does that make sense? So if this is no greater than, which means all the points is included. If it's equals to, it's just on this line. It's just on this line. So that's why I said it's okay if you ignore like the no greater than and replace it with equals to. Yeah, right. Mm-hmm. So I just don't draw this shaded area. So it's just this line, it's budget constraint line. And graph the consolidated constraint equation. That's how you graph it. It's just a line. And what's his point? Yeah, the question is if I put AOG on the y-axis and Netflix on this side, and this is 0, and what's his point?
320.
320?
Mm-hmm.
If this is 320, which means when you consume 0 Netflix, you got $320. We check with our equation. If Netflix is 0, this part will be 0, right? This part will still be 0. And if Netflix this will be 0, and AOG will be 320. Yeah. So that makes sense. I think some smart people may try to write like the 319 and 0.5 here because there's a 0.5 here, right? But this is wrong, since it's only conditionally on you consume the Netflix. Mm-hmm. And what's the slope? What's the slope here?
20.5 minus 20.5.
It's just 20, minus 20, negative 20. As this part is like the fixed cost, it's not going to change with any additional hour of Netflix consumption. It's a fixed cost. Okay, so that's why I'm wrong in my last office hours. Yeah, so here it's only 20, and it's not 20 actually. When it's at 20, you will be marked off since it's negative 20. Always remember, this is very tricky, and you don't get this wrong. The slope will be negative.
Could you explain why it's negative? Because I'm thinking it more like it's price of Netflix divided by price of all of the goods, right?
Yeah.
So price of Netflix isn't that
20. Price of Netflix is like the wage, like the salary. Like okay.
No,
Yeah, it's a PX.
Yeah,
You got it?
Okay,
Yeah, I'll explain this later, and don't worry. So here is negative 20, and why I'm going to show you. So here, just let's solve this point first. For this point, if you spend all your money on Netflix, how much can you get? 16 or 15?
15.6.
Yeah, it's actually this number over 20. Since when you set AOG to 0, right? When you set the AOG to 0, you got 20 Netflix plus 0.5 equals to 320. So you subtract both sides by 0.5, you got 19.5, and you got 20 Netflix. So over 20, that's this point. So I didn't solve this. You can continue with this, but this will be, if you use your calculator, this will be your answer on this side. And the slope, sorry.
Yeah, so 0.05 is only when, okay, so that's not into Netflix.
Yeah, that's actually.
Yeah, so we were doing the mistake probably
Yeah,
last time.
Exactly. So this part is a fixed cost. So when you like for this part, I may extend a little bit. When you supposing you are just running like a burger store, right? You are cooking the burgers, right? And the variable cost will be like for one burger, you $2 on the flour and $3 on the butter. Yeah, okay, it's just flour and butter. It's a very simple burger, and that's a variable cost. Yeah, I make it simple. Okay, that's a variable cost. What about the fixed cost? Here, what's the fixed cost here? If a burger store, any
Storage.
Yeah, maybe, yeah, the store.
Maintenance cost.
Yeah, if you spend $10,000 on the store, that's your fixed cost. And if you want to like calculate your total cost, and you just produce like 20 burgers, how will you do this calculation?
10,000 plus 20 times flour and butter.
Exactly, it's 10,000 plus 20 times 5. And you see here, this is the price. And that's quite the same like this, right? This will be the fixed cost, which you don't have to multiply it by 20. This is the fixed cost, and this is the variable cost, which is $5. This is the variable cost in total, and you have to multiply that by your quantity. Okay, so here it's quite like this. This is your quantity. Here the quantity is the difference here is $5 is the cost, and 20 will be the quantity, and we don't know the quantity. We just use the letters to stand for the quantity.
What is this part C right now?
Yeah, it's part C.
So what was the opportunity cost here?
It's 20.
20
It's just
only?
20. Yeah, it's just 20.
Yeah, 20 not 20.
Exactly, you're right. And so here's a graph for like the question C. Any questions until now? Question C, A, B, C.
So for B, do we just like by term? Do we just write
Yeah, as simple as you can. I mean,
measure?
yeah, it's
do we
20.
need to give? Okay.
Yeah, the number is 20, and why? That's because the opportunity cost is you consume one more, and you're losing that part. You're losing your wage, and the opportunity cost. That the definition is you can Wikipedia, and I think one sentence that's enough. Okay. Yeah, right. So question D, and B here's like the calculation part here. Yeah, tell me. We are on question 7, number D. Yeah. and I record like the previous part, so don't worry. What is the optimal allocation of NF and AOG? We got one equation here, and if you remember what I said in the previous, in one previous office hours, you need two equations to solve like the two unknown numbers, two unknown quantities. And one equation will be the budget constraint. Well, 0.5 plus 20 NF plus AOG equals to 320. And the second equation will be the MRS equals to the slope. Which means we got a tangent solution here. This is the optimal bundle, and the optimal bundle should happen when it's tangent. And the tangent, the slope, this will be the slope of indifferent curve. Slope of indifferent curve. And this will be the slope. Here, slope, I mean the slope of budget constraint.
So this would be 20 because last time you were taking 20.5.
Yeah, exactly. And this will be 20, the slope of the budget constraint. Since I, from the question part C, you know that it's 20. And why is 20? You can also use one simple. Remember, it's px, the price of good of x over py, the price of good on y. Price of x here is p Netflix over p was AOG. And Netflix, what's the price of Netflix? Remember, opportunity cost, $20. And AOG is defined as 1. So it's close to 20. Here is px over py. You have to put the negative side. If you want to put this on the graph, because we are doing only calculation here, so you can leave the negative sign aside. We're just setting the numbers equals to the numbers, no matter it's positive or negative.
I'm sorry, could you one more time touch on where, like, this is the part that kind of hung me up, was like at 0.5 for my Netflix price, and I guess 20 is your opportunity. Like, it was hard for me to.
Yeah, exactly. Here, I think you only take like the variable cost into consideration. Leave the fixed cost aside. You ignore the fixed cost. Since the fixed cost is like part of your income, you spend your income and your income goes out. You see, it's like the 0.5 will not be taken into consideration. And this, like the PX, the price of Netflix, is only the variable cost. It's only the variable price. It's only like the $20, like the wage.
So, like, because I know in the book they give income and then they also give the price of a commodity, right?
Yeah, right.
But then they use the price of that commodity for these slopes.
Yeah.
Now, I understand why that 20 is coming from because it's opportunity cost and all that. But then again, like, I don't know when we can, and this is sort of going out of this question, but how do we figure out when we are using actually the price of that commodity versus the opportunity?
Yeah, sure, exactly. Always use the price of commodity. This is like the, it's a like more exploration question or something. So I mean, for like the basic level, and I think price is enough. Always use the price. Price is enough. And here, if professor gives you like the question of this on the exam, I tell you what you should use. Use this. Yeah. What is on the NF? What is associated with NF? That's a price. Okay. What is associated with NF? And this part, though it's conditionally on NF, but there's no like the coefficient of NF. It's not a coefficient, but here is a coefficient. So this will be the price. That's a trick how you can identify. And you may, I mean, for me, even I don't know how to explain this. I just from my experience, I know this should be the variable cost, and it should be the price we used here. So it's 20. So the slope also you see if you draw the graph, the slope is 20. It's negative 20. And for the MRS, I think you know it's mu x over mu y, right? Marginal utility of x over marginal utility of y, which they have given you. The marginal utility of x is marginal utility of Netflix, which will be 40 over square root of NF. And the marginal utility of y will be 1. So it's just so if you set this part equals to this part, what will happen? I will write it down here. 40 over square root of NF equals to 20. First, multiply both sides by square root of NF. You got 40 equals to 20 times square root of NF. And then you just divide both sides by 20 is 2 equals to the square root of NF. And NF equals to 4. Yeah, if you square both sides.
Oh.
Yeah, square both sides, this will be 2 square will be 4, and this will be NF. So the quantity of Netflix in the optimum bundle, like here, will be 4. And here will be, what's the AOG? You just plug this back into this equation. If this is 4, yeah, you only got one unknown number, and then I think you will be able to solve this. Yeah, be careful on your calculations. And yeah, I will tell you the answer. It's this number for all other groups. 239.5. 4. Yeah, I'm sorry for like the scratching over the blackboard, but it goes here. You set this equals to this, and which I do a calculation. I do some calculation here. And you plug 4 back into the budget constraint, you got your AOG. Okay. Yeah, we only have limited time, so I have to really quickly. Yeah, I'm going to draw a bigger graph.
I graph food spoke to a couple of Indians came back. We weren't in the data science one also.
Okay. 31.5 over 20. Okay. That's our budget constraint. And now, because we are decreasing wages from $20 to $15 per hour, yeah. So what will this change to our budget constraint? I think you have to think about like the budget constraint here. Plus 20 Netflix plus AOG equals to 320.
So this
And there are 2 changes you have to make. What are the 2 changes?
16 NF.
Yeah, first is this one. It's price, right? The variable cost, the price change, the way, the opportunity cost is the price and is the salary. So when your salary decreases to 15, you have to change this number into 50. So plus 15 NF plus AOG, and what's the other change you have to make?
15.
Yeah, like the total income. When your salary is exactly when your salary is 15, and you can work as most as 16 hours. So your total wage cannot go beyond, go above 16 times 15, which will be 240. Okay, will be 240. So you can see, usually we got a question changing only changing the price, and the new graph will look like this. Right, will look like from this point to this point, but now you have to change this point to 240, as your income also decrease. All other goods you can consume is only 240. That's your maximum income. So you change this to 240.
Do we need to show that as well?
Sorry.
Do we need to show that?
You don't have to. You can directly do calculations. But I'm using this graph to help you understanding all the situation. And if this is 240, what will be this part? If you set, if you set like the Netflix to 0, AOG to 0. If you set AOG to 0, this part is 0, and will be 2, 3, 2. Yeah, go down this or this side. Oh, I shouldn't draw it like this. The price is cheaper.
It should be parallel, right?
Yeah. That's it.
No, but it can't be parallel also.
Sorry.
It won't be parallel.
Parallel. It's not parallel.
Not parallel.
It's not parallel
Because
the
the slope
price.
has changed.
Yeah, because think about why it's not parallel. Think about like the slope. The slope for this line is, remember
15.
what I told you, the slope of the line is
Minus
15, and 15 is now equals to 20. Actually, it's smaller than 20. So it should be flatter, and it should be,
It's bigger than.
Yeah.
So,
but it's
so it
flatter.
should be flatter.
Yeah, it's flatter. And here will be 239.5 over 20. That's a graph. And then, actually, you don't need this graph to solve this question, but just do some review and try to understand what happened and to associate like the slope with the equation.
Wouldn't it be over 15?
Yeah.
Exactly. I'm sorry.
Okay.
Good point. Hey guys, it's 15, okay? It's 15. And now, let's do this. And because preference doesn't change, which means the MRS, the equation, like the MRS doesn't change. So the MRS will still be 40 over NF equals to 1. No, sorry, not equals to 1. Equals to over 1. And we set this equals to like the
15?
The price ratio, it's 15 here. It's 15 here. And use this equation, you can solve this. And you may have a question. Also I have this question. Why we only need one, like the form one function, like one condition to solve this? Usually we have 2 unknown numbers and we need 2. Here is because it's like the perfect substitute. It's a perfect substitute, and which means this quite special. It's a very particular situation where you can directly use 1 to solve. Since the MRS, we only have NF here. We only have one unknown, like the one letter here. Usually it will contain NF and AOG, and then you have to combine those 2 equations when you have NF and AOG.
Could you explain that again? I didn't catch it.
Sure. Here we only need this equation. We only need like this function. MRS equals to the slope. We can solve the NF. But why? Because we only have NF here. What if this looks like 40 times AOG over the square root of NF equals to 50? You have to use like the budget constraint. Here we don't have to use the budget constraint. We can directly get the answer. Why? Because it's perfect substitute. And for that part, you can explore a little bit deeper. I won't explain too much on that since it will distract too much. But here, that's why. That's why we only need one equation. And that's professor is like trying to be inconsiderate here. To give you only one. Here, if you do algebra, you can do algebra on this, and it's quite simple. You can get like the NF should be 7.11 hours. And note, this is still greater than 0, which means you can add like the 0.5 fixed cost. This is still greater than 0. Remember, conditionally on NF is greater than 0. And also, this is smaller than 16, which means we can consume this amount of Netflix. If it is greater than 16, you have to do a lot of, you have to analyze the graph and see if we should choose a corner, or maybe we should choose somewhere else. But here it's good. We don't have to do anything to the graph. And you plug this back into your new budget constraint, not your. You have to plug this into a new budget constraint. You check the video. So, then you will get the AOG, which will be 132.85. That's like the answer to E. And your new bundle will be 13.5. Will be here. This will be 7.11, and this will be 132.65. And that's your new. I call it B maybe, or maybe you'll call it C. I forget. It's A to B to C. The deposition point.
So there's one more part to this question. Explain why it is or not consistent with the quasi-linear preferences.
Quasi-linear preferences.
Well.
So consumer has quasi-linear preferences. So what is quasi-linear preferences? Do you remember? You have to
So
how much you want doesn't change with income.
You
would purchase the same amount of goods.
For any quantity, of X good, the slope remains a constant basically.
Which means you have
Which means for increasing utility, you will be still consuming the same amount of X.
Usually that happens with perfect substitute, right? Perfect substituting situation.
So this is a perfect substitute. And the income effect is 0 in quasi-linear equations. So, but we still have an income effect, right?
Not happening here. Yeah, I see. So I think the quasi-linear, what's that called? The quasi-linear preference. The preference, when you do like the income change, it's only about income change, right? If the price, I mean, usually when it's only price here, it's very complex. I think your answer can be this situation is very complex because when you change the price, you also change your income. When you change your price, like the opportunity cost is the price. When you change like the 20 to 50, you also change your income, and that's why this situation is very complex. And yeah, I think that's my current answer. Since I really have to review like the idea of quasi-linear, like the preference, but I think that's enough for you to get the point, because it's changing both the income and like the slope. Yeah, usually I can draw two graphs for your reference. This is an income change. It's parallel. It's an income change, and this will be a slope change. It's only slope, but the total income doesn't change since you can still buy all the goods here. And when these two graphs combine together, we get here. Then some assumptions can never hold. And yeah, and you're right. And for this question, I will note this down. I will try see if I can answer by tomorrow. I maybe email you on this. You got a pen.
Yeah.
Thank you. Circle this one. Okay. So that's all for question 7. Question 8, which is a lot. And I mean, the hardest part is not answering the questions. Actually, it's understanding the questions. It's how you understand these questions. So for here, I will directly lead you to the answers. And if you have questions, yeah, feel free to raise your hand. Question A. Yeah. Question A. The question is long. So actually, you can ignore everything else. And here it's asking what are the problems with highly subsidized electricity provision. And this is kind of misleading since it's kind of asking you about like the problem with subsidy. Actually, here it's not subsidy. Here the situation, this is a graph for subsidy. Okay, this is a graph for subsidy. The quantity is greater than the equilibrium quantity, right? But here, the graph should look like this. Since like the cost, like the supplier is supplying at a constant cost. So this should be the graph. And this is the equilibrium point if the price is cost recovery. Here, because of the government is supporting, making the cost really low, and you reach this point. This is P, this is Q. Here is here is P and Q. It's not like one good and another. It's nothing about like the budget constraint and its price and its demand curve again. This will be the demand curve, and this will be the supply curve 1, supply curve 2. Oh, sorry, supply 0 and 1 maybe. And it's flat because the price is constant. You are facing a constant price. I understand this. Like all the producers are producing at a fixed cost. They are not producing at a different cost, which is increasing. They are all producing at a fixed cost. And the problem with this is, first, what's the problem with a fixed cost? You see, you tend to consume more. You tend to consume more than this quantity. This quantity is greater than this quantity, than this one. If we have an increasing cost, if we have a normal supply curve, right? Here a flat supply curve, you already tend to consume more, and the government even lower the price, so you will consume much more. And like the answers to this question is, you will have inefficient demand. You will have like consume more, which you don't need.
So according to the example, he says that consider a specific example such as a household considering investing in improved insulation for living quarters, and the answer would be that they won't consider investing in insulation because they're getting subsidized electricity.
Exactly. You do got the idea of insulation and insulation and the electricity, right?
Yeah.
There are all ways you can keep yourself warm. Insulation is you stress it. I mean, you just build your house warmer. You just spend some money on your house. And the electricity is you just maybe use the electricity to keep yourself warm. So it's like two good here. It's like one good is insulation and one good is electricity. And the problem here is you spend too much money on the electricity because it's very cheap, and then you may spend not enough on the insulation, which means all people are living in really bad conditioned house and spending a lot on the electricity. Not spending, it's consuming a lot. Actually, not spending a lot because the price is low. Consuming a lot electricity to keep themselves warm, but ignoring about like the house conditions. That's what's happening. I mean, what was happening in the Soviet Union, post-Soviet economies. Sure. So that's answer to question A. This graph, you don't have to draw this graph. Sentence.
So what do you want us to like?
It's just like the consumer insufficiently consume more.
Okay.
Yeah, than the efficient amount. The inefficient word is the key word here. You got the inefficient, then you got the point. Here, everything is about. I mean, you will hit these points in your macro 2 and the public finance next semester. But I think professor just wants you to beat you really hard. To treat you knowledge. Yeah, actually this shouldn't be on this course, but it's good to get an idea of what's going on there. And question B. Actually, when I read these questions, I first count how many question marks are there, so I can know what he's asking. And usually there are more than 2, even 3 question marks. I got really confused. For this one, it's easy. You got only 1 question mark. What's the problem with raising historically low rates to cost recovery? If you continue on this, if we are deleting this, erasing this, if we raise to the cost recovery rate, to this price, then what's happening? What's a problem? So here, the main problem will be if you raise it, people are consuming less electricity. But consuming less electricity is not a problem. The problem is if they consume less electricity and they cannot they cannot they cannot keep them warm from the good conditional house, then there's a problem. Which means people don't have time to, or maybe don't want to spend money on changing the conditions of the house, to spend money on the insulation. And then you raise the price, which means some people may, what's the word he used here? They will be unhappy. Like the unhappy the word here.
So one other question.
Sure.
Yes. So whenever there is a change in price, and when we look at demand, so are we also supposed to look into short-term demand and the long-term demand? Because it would be demand inelastic. People would be like, if the price increase, people won't really care if the price increase.
Yeah, exactly.
Initially.
Exactly. Here is just intuitively. Your part is going to like analysis, but here is intuitively. That's like intuitively what's happening. And for the elasticity, I think there's one question about that, and you can do some analysis on that part. Here, that's enough. People are getting unhappy because the price raised and that they have to insulate their house, but they don't want to, or they don't have the money. So they are worse off. They are worse off. That's the problem. We don't want people to be worse off. Yeah. Here, like the keywords, I also tell you the keywords. Keywords can be unhappy, like the insulation, and like the can't afford something like that, and that's enough for you to get the point. I mean, I'm not grading yours, so sorry. So that all these can be lies. If Eric just mark you off, you can go to me, but just. I don't know. Okay, I don't know what's going on. That's my understanding, and that's what's on the answer key. So that should be fine. I think you should be fine. And question C. Yeah, but I will grade yours. So pay attention. I mean, for those who are watching this video from the class, yeah, I will bring yours. Okay, so question C. This one is a long one, and actually they are giving the professor is giving you a solution. Our question C, from question C to C, D, E, F. The following 4 questions will be on this situation where the government is trying to solve this problem, and the first solution is a tiered pricing strategy. I think you go through the paragraph and you know what that is. It means you consume to a certain amount, the price suddenly goes up. Okay, the price suddenly goes up. And for this question, what did they ask you to do? A graph, yeah, I think it's a graph. Paying full cost. From an area of consumer surplus and the area of government revenue. That can be easy. So first, how many demand curves are we going to draw? 2, maybe. I think 1 more, because 3, like the 3 consumers, right? 3 consumers are facing 3 demand curves. I think there are like the who consume little, and who consume medium, and who consume a lot. Yeah. So 3 group of people. Did he mention it here?
For each, like draw separate graphs of 3 different types.
Yeah, above the level, exactly at the level and below the level. So we assume this is the level. Okay? We assume this is like the medium level. It's a level which can keep you as a keep you
warm, I guess.
Yeah, exactly at the subsistence. And this is the level below, and this is the level above. So why this level is higher? Maybe you can draw a line here. For certain price, the high demand group will consume more than the medium demand group and than the low demand group. If you draw a line here, it's the same price, and this group consume more. So it's like the who will consume more. This is just high demand. This is the medium, and this will be the low. So that's the first you draw 3 demand curves, and then you draw the supply curve. And the supply curve, let's try to do the original supply curve first. The original supply curve is like this, right? It's a very low price. And the price is what? If we don't have any solutions to this, what's the price?
0.15.
0.15. And now the government wants to raise the price when? After the quantity go beyond like the 150. Okay. So when it goes to 100, maybe it's not here. Maybe I draw it here. Here is fine. So it should not be here. I mean, it's just a random line.
But medium is also the one who are exactly at subsistence level, which means they are consuming 150 only.
They are consuming
150 kilowatt hour per month.
Wait, what?
So there are 3 groups, right? The one which is consuming less than 150, the other which is consuming
more than
150, and the third is the one who's consuming exactly 150.
Yeah, exactly. And once you draw the supply curve, we will find why they are consuming exactly. Okay. So for this group, if the line is here, right? If we assume it's here, and we draw a line like this, does that make sense to you? This line, this is I tell you this is like the supply curve. Does that make sense to you?
Mm-hmm.
It goes here and suddenly raise the price, and this will be the equilibrium point for the medium group, which will be exactly 150. Is that okay? Which will be exactly 150. Yeah, you can draw it. So that's why I told you can draw you can draw it here, but you have to make this line cross with this demand curve. So you can cross at 150. You can cross at this level, which means the medium group, or exactly at the subsistence group, consume 150. That's what's electricity. Mm-hmm. So here, this group will consume this number. You don't have to give me this number nor this number, since you cannot calculate. You don't know the function of the demand curve. All information you have is this will be 0.45. right? This will be the price will be 0.45. This will be 0.15. This will be 150. That's enough. And you don't know this point. You don't know how much like they are paying. You don't know. Because it's actually this doesn't make sense. It's sudden increase. You can see they are paying either this price or this price, but they are consuming like the.
So exactly. So shouldn't that point be on that line, like the bottom point?
Which one? Which one?
Yes.
Should be on this line?
On medium one.
On medium one?
On the medium line, shouldn't the bottom like 0.15 intersect there only?
Intersect with a zero only.
Like the medium and the 0.15 line should
medium
intersect.
And, you mean this point?
Yes. Shouldn't it be this point?
You can. I mean, you can. I mean, what you're talking about is like a graph like this.
Yes.
It can be like this, but it can be like
because
this.
that way they aren't paying any other price. Like,
but wouldn't that go beyond?
But that's very tricky because you got this point and this point here. Why aren't they paying like 0.45?
no, because the equilibrium price. Is
Yeah, because
that way.
the contest didn't give you that information. What exactly are these group are paying, right?
Okay.
So just ignore that part and you can draw either this way or that way. That's fine. I mean, if you draw that like that, yeah, you are right. If you draw like that, they are paying this price.
Yes.
They are paying the lower price, but
Exactly.
maybe the government wants them to pay the upper price.
Okay.
Yeah,
Oh.
you're right. And you're right. So that's the answer to question C. And you can label this and this here.
So it also says that for each graph, identify the area of consumer surplus. So one is
Oh yeah. So here is like this area is like the price. Here is tricky because the producer surplus is 0. Yeah, because if it's a line like this, you got this area as the producer surplus, but if you rotate it, you can assume you are rotating this line until it's flat, and the producer surplus is getting 0, but the consumer surplus will always be this area. You see, the only thing changed with like the upward sloping supply curve and flat supply curve is the producer surplus. It's nothing. I mean, sorry.
Is
sorry
that
for this
for
one.
what? That's for when the price is 15
Yeah.
cents, right?
Exactly. And for this, it's this area. It's this area. It's this big area. And for this point, it's like this area.
Including the. So
the
that would be-
producer surplus is 0 in all cases.
Yeah, it's 0. It's this area. For the medium group, it's this area.
Okay, median is that,
Yeah, in this area. It's like the definition of the producer surplus. Yeah, I mean, I think I emailed professor on maybe he should give you some questions to see if you do understand what's the consumer surplus, but I'm not expecting a difficult one like this.
So do
So
we
that's a
need,
test how. Yeah, that's a test kind of.
do we need like 2 or 3 different graphs itself? for this question?
Yeah,
Or-
I have no idea on that I should say because he is asking like 3 graphs maybe, but the answer key only 1 graph. So I don't know. Maybe you should draw 3 graphs. Yeah.
Does the consumer surplus go down to 0.15 or?
Oh, you mean here, this area, right?
Yeah.
Yeah, it depends. If you go down to this point, you are assuming the price they are facing is 0.15. But I'm assuming they are paying some price in the middle. So you just mention your assumption. What's your assumption? They are paying this price or like the higher price, and then you can guess your answers. You just mention your assumptions.
So what is the question asking?
The question asking,
Would it be?
So that is ambiguous.
Yeah, that is ambiguous even from the answer key, I have to say. Exactly. So if you lose point on this, you can argue. This is like the middle area where you can argue. You can always argue. But for some part, yeah, if it's 2 and the writing as 1, you cannot argue, right? But here you can argue for it, like whether this area or this area. But do not go to this area. That would be wrong. Yeah, this is nonsense. Sorry. Yeah, okay. That's question C. Question D, how many question marks? Oh, actually 0. Oh, this is very tricky. I have to read all the questions. illustrates the pricing scheme in consumer model where consumers are choosing between purchasing. Yeah. So here you are using like a demand model. I think you can call it PQ model. It's a price and a quantity. It's a demand model, right? You put price on this side and you put quantity on this side. It's a PQ model. And now he's asking you to use like the two good model, X and Y model. You put X quantity and Y quantity on one on Y and one on X. Okay? You put two quantities here. Let's do like the D. The budget constraint for like the the budget constraint for consuming two goods. One is insulation. Maybe you put insulation here. And why we put insulation here? Because the price for electricity is changing. And if the price for some good is changing, put that on the X. Okay, put that on the X. So that makes life easier. Since you are doing the slope as Px over Py. So if the price of X is changing, it makes life easier. You can change the numerator instead of the denominator. That's why you put it like that's why I put and we all put like the electricity on this side and insulation on this side. I should draw a better graph. Electricity and insulation. Okay. And draw a budget line. You don't have any specific numbers, so you can just draw a line like this. It's a budget constraint, right? It's a budget constraint like this. But this is not correct, since the price changed at some certain point. So I just draw a line like this. And what happens when the price goes to here, which is 150? Sorry, it's not the price, but the quantity. When you consume 150 of the electricity, what's happening to the price? Will the price be higher or lower for this?
Price will be higher. So
well, if the price will be higher, then will that slope be steeper or like the flatter? If you see Px over Py, this is the slope, right? You also have to take the negative side. So Px is increasing, so the slope number, the number of slope is increasing, so it's more negative.
yes.
Okay. Px is increasing, slope, number of slope is increasing, so it's more negative. You put a negative sign. It's more negative. Well, when you draw a more negative graph, it will be steeper. And you erase this part. That's something we're expecting for question T.
So we just draw one graph.
Yeah, I think that's enough. Dude, I mean,
Then we have to make the utility function. So one would be on the point, one would be above,
exactly. You
and
have
one
to
would be on the lower
So
one,
we
right?
need to draw
That's why the long questions always distract me. I hate long questions. If I were you, I really will lose some points on this. Don't forget to answer this. So one on this part, one on this point, and one on this, right? Yeah, you can just 3 points, and for this one maybe you draw a curve tangent to it. For this one you can draw a curve tangent to it. For this one you can draw a curve tangent to it. And these three curves can intersect each other.
Oh, okay.
Yeah, why? Because they are different. They are for different groups. They are not for the same person. In different curve, the ICs for one person, in different curves for one person cannot intersect, will be parallel. But they are for different groups. This is group A, group B, and group B. So person A, person B, and person C. So they can intersect each other. So just draw three in different curves like this. And label. Sorry, I have very bad habits, so don't take these parts with you. Always label everything, and that would be great. Like the IC1, IC2, IC3, and this point is like the king point, and this will be like the you don't get the number, but you can label it as R, E, E, and I, and A, B, C. Yeah, so this is very important in exam, Actually, showing you a mark off, I don't know, mark line.
So also like we could have used instead of IC as we could have said utility curve.
Yeah, exactly, sure. That's just about. Yeah, it's just you can use U. Actually, you can use O or R. Better use something everyone is familiar with. Yeah. It's just the labeling. Okay, for E. That's for E, right? Okay. Oh, is that for E? That's for D. And question E. Question E is interesting. So we got one concept here, which is called technically efficient. Technically, okay, TE, okay, so I don't have to write all the things. Technically efficient combination means the price accurately reflects the cost. So on this graph, which price reflects, which part reflects the cost? On which part the price of electricity reflects the cost? Which part? This part or this part or this point? Reflects the cost. What's the cost recovery price? It's a higher price or the lower price?
It's a higher price.
So the higher price part reflects the cost.
Oh.
Does that make sense?
Yeah.
Because this part is the cost recovery price. So this part actually, this part of the line where you have a higher slope, you have a higher price, reflects the which reflects the cost. So when you are choosing a bundle on this part, you are doing PE, you are doing technically efficient way of the consumption. Now if you are choosing points over here, you are not efficient. Does that make sense? This part, no, not efficient. This part, efficient. Technically efficient. Why? It's really confusing since any optimum bundle, if you choose the idea is if you have chosen an optimum bundle, then it's efficient because you are allocating all your resources as good as you can. Sorry. Mm-hmm. Any bundle will be efficient. Any bundle you choose will be efficient as an economic guy. But here we are talking about technically efficient. Yeah, it's not only efficient. You have to be technically efficient, and you get the definition, which means you are choosing the price reflecting the cost part. Price reflecting the cost part.
So I have a question.
On this one,
It says yes. It says that define technical efficiency. So shouldn't it be a function of your income and the insulation and the heating expenditures? So something like T is equal to A times I by H or something like that. Inverse proportionality.
No, I don't think Professor even got that part. No, don't worry. No, don't go that far. Sorry. Yeah, your idea is great, but I think that's something including. This is a paper he did when he was at the World Bank. So it's a research paper, and I think he may go that far to that. But for you, don't have to think that far. Just use the definition. Directly use the definition as the price is reflecting the cost. That's good. Price is reflecting the cost, and from that you can go deeper on that part, but don't have to. You don't have to.
So could we just illustrate this from just one diagram? Because it does say in each of these three cases above, tell whether the consumer is. So it's not being achieved when it's below 150, but it's being achieved after 150 once the price rises, right?
Yeah, exactly. And I suggest you to use low, medium, and high to classify, as that's what the answer key has been used. And I think maybe Eric may be grading, based on this, instead of the 150, the number of 150. Use the low demand, medium demand, and high demand. Actually, the low demand is below 150, medium is exactly the 150, and the high will be over 150. But using the low, medium, high is consistent with the answer key. So
do we need to draw something like that in some
no, just directly say this is a low, this is a medium, and this is a high.
So one other thing, so the question actually says, so when we are talking about that graph is technically efficient from a government standpoint of view.
It's efficient it's not technically efficient.
Because it says that the consumer, tell whether the consumer is achieving technical efficiency in heating. So it doesn't mean it shouldn't be that part, right?
It should be this part, yeah.
No, because it says the consumer is achieving technical efficiency in heating, which means the consumer is actually paying a lot more at this part of the graph. So
At
how
this
is it
part.
technical efficient for the consumer?
Because they have high demand. They have this, these are different groups. It's not for one consumer. They are making choice between this and this and this. It's for different groups. It's you can think of 3 people. They are making their own decision. And the people here, the person here is not technically efficient. Even though he finds himself efficient, but he is not, since the price does not reflect the cost. And the person here, maybe, but you can classify as this part or this part. And the person here is consuming technically efficiently, is consuming in that way, because the price is reflecting the cost. And that's from the definition. It's like the, so not that intuitively. You better focus. Start from this question and answer this question on this part. Since even I don't have a clear idea what is technically efficient. I have to admit.
Because it says that the consumer is achieving technical
that's
efficiency.
why. Yeah, exactly.
Which means the consumer should spend less to get more of.
For that, then let's discuss this. Would they need to spend more money on insulation or electricity to achieve that? For that part,
they should spend more on insulation.
Yes, they should spend more on insulation. And why, I don't know. Yeah, that's my answer. I don't know. From the answer key, I even don't know. I don't know why. Okay, but saying that may get your point.
But the thing is, I think the reason is that if they're spending a lot more on insulation, so for starters, then they'll be spending less on electricity.
They were spending less, like on the last.
On the electricity, and they'll be on the higher part of the.
Yeah, I understand Hart's the explanation. It's because the price is, the problem here is the electricity. And if you spend less on electricity, you will not face a problem. Does that make sense? The problem here with whether TE or not TE is about the price of electricity. Whether you are consuming the price of the electricity at this or at this. So if you spend all your money on the insulation, you do not have this problem. So it's technically efficient. Yeah, that can be why the answer says allocation is technically efficient when you spend more money on insulation. Remember that. Yeah, the crucial point is spend more money on insulation. And if I am grading, I will ignore everything else. I will just look at this part. Yeah, great explanation. I think you answered my question. I don't understand about the answer key here. So F, let's go. Yeah, we only have 20 minutes. Let's finish. Question F. In this scheme, there's a trade-off between generosity and technically efficiency. Okay. So when we are going to analyze the trade-off, the trade-off between A and B, what does that mean? That means when we get more A, we will lose B, right? And here the professor asks you to explain why this happens, right? So you just go from when we are getting more A, we are losing B as a price, as a cost for that. If we are getting more A by losing B, then it's consistent, or that's something it implies. Do you get my point? So what we are expecting here is, by getting more generosity, which means by giving out more money, you have to lose, you have to pay a price of the, losing PE, the technical efficiency here. Mm-hmm. Yeah, I will say one more time. So the trade-off between A and B means if you're getting more A, you are losing B. So here, if we replace A with the generosity with G, and B with TE. So if you are getting more G, if you are getting more generosity, you are losing TE. And if you want to demonstrate that part, if you want to explain that part, you have to demonstrate if you are giving out more money, which is more generous. If you are giving out more money, you are losing technically efficiency here. And why is that? Is from this graph, if you are giving out more money, so if you are giving out more money, who will get this kind of transfer.
And consumers.
I mean, the low demand or the medium demand or the high demand will get more of the
High. The high demanders will get more.
let me see, right? It should be the low.
Oh.
Explain the implications of generosity, the benefit of. Explain the.
What's the scheme? The scheme is what? Scheme is reading. Visual transport.
Oh.
Yeah, actually, I can give you the hint here. The hint is here. When you're giving out more money, the low and medium group will get more transfer.
Yeah.
So we'll give an incentive to. I mean, we'll incentivize the high group to transfer to the low and medium demand group. Then if they transfer, they are transferring to somewhere not technically efficient. Because this part is what we are saying is, if you give out more money, these people will tend to choose these bundles, and then it's losing. You're losing the technical efficiency here. That's the answer. Why? I mean, why when the government raise the level, the subsistence level is raised, the low and medium demand is getting a bigger transfer. Why is that? Oh yeah, maybe because if you are raising this, then you are excluding excluding the high demand group. You see, if it looks like this, then all these people, sorry.
The subsistence level would be this only, right?
What
So
is
we
this?
are just increasing this part.
Increasing this part to here. Okay. If I'm increasing this part to here, or maybe to here, if we increase enough to here.
Oh, so that's being okay, right.
Yeah, if we increase this part to here, if we increase from this to here, to this part, then
Then the high.
Then the consumer surplus would increase. Like, how is that a good thing?
So isn't that what he's asking?
yeah, I mean, I got a little bit confused here. Yeah. Actually, I have to admit I don't got all the answers, but here the reason, the process is, if you are giving more, if you are as a subsistence level raised, low and medium demand consumers get a bigger transfer, and that will incentivize the high, this part, this group to be this group, and they are losing the technically efficiency here. Yeah, because we demonstrate that this part is not technically efficient, and this is technically efficient.
If they're increasing subsistence levels, shouldn't the higher demanders be getting more benefit now, because the lower demanders are getting the same benefit?
Why was that? I mean, when I was looking at this question, I thought I got it, but it turns out I didn't got it.
But I think it's because, as you said, the demand curve is the willingness to pay. So if the subsistence level increases, more people would start spending more, would start consuming more electricity, which is why the low and the medium would start consuming more, because the subsistence level has increased.
Yeah, I mean, that makes. But I really cannot get that information. Sorry. So let's move on. Let's leave this part here. And remember, the crucial point here is when you, when you give out more money, you will encourage the high demand people to be the low demand people, and then you will lose technically efficiency here. That's a whole process, and I think that will get to the point. But for why, you can discuss with Mike. I mean, he designed all these questions. Yeah. Ask him. Yeah, don't torture me. The G. Question G. Question G here. Yeah, and I think there might be one more question I didn't get it. Let's start with G. Okay. We discussed two compensation measures: equivalent variation and compensating variation. Equivalent variation and was compensation variation. Yeah, for these two concepts I forget, so it's okay if you forget. So, and you don't have to use these two concepts to answer this question. So you can ignore them, but it's good if you can review. Okay, I really forget, so let's throw them away. What information about the household is required to calculate the measures? So, but even though we forget these, but we may know what measure we are going to look at. The measures here means how much you want to, right? How much compensation you want to give out. Yeah, and maybe it's easier if we put it in an easier way. You always want to solve a bundle, right? We always want to solve a bundle. And if we want to solve a bundle, what information do we have to have?
Final basket initial.
We have to have like the two conditions, like the budget constraint and the utility curve, right? That's the two equations. And here, what information is required? It's just the budget constraint and the utility function. Budget constraint and utility function. That's always something you required. And will that be feasible to calculating in practice? Everything in practice is not feasible. So this is not feasible. Yeah. All these are series, or no? All these are series. So everything in practice is not feasible. So it's just to say they are not feasible to do in practice, right? Because in practice, you can. I mean, you will change your mind. You will always change your mind. You will not strictly follow the budget constraint and the indifferent curve. You don't know what's your indifferent curve, right? What's my indifferent curve? I don't know. I don't know what's my indifferent curve.
So like. What I'm not getting is like, why is he talking about like there's direct compensation, but he doesn't explain what's the purpose of the direct compensation? Like I don't.
Direct compensation.
So another policy tool to mitigate the impact of a price increase.
Oh yeah, I will show you in the following part. Yeah, what's about like the idea of the compensation? Like the compensation here is like put it in an easier way. Yeah, one sentence. Compensation, like here, is like increasing the income. Okay, compensation equals to increasing their income. Like you can usually when we are dealing with this graph, we are dealing with like the budget constraint and the indifferent curve graph. We are dealing with this graph where we put a good like the y go down here and x go down here. We usually have two policies to influence. First is income. We can change this, we can change you remember I draw the two graphs here. One is about the income and one is about the price. Usually that's how the two methods we have. And the compensation here is we are using like the the income method. We are giving them incomes to make them better off. We are giving them incomes to make them better off. So H, let's look at H. Yeah, right. Those price increase and compensation. Okay, so first, the increase of price. Let's go step by step. If you go to the final, if you go, this is quite long, so for those who are losing, for losing here, just refer to the video. So yeah, that can be good reference. And
which question are we?
Question H. Question H. Yeah, you are losing here. Question H. Yeah, question H. The question here is, let's look at it. Would you expect to remain at the original basket after compensation? How much should be compensated? Okay. Oh, such a long question. I hate this. I really hate like why? It's three questions in one. Why don't just make G, H, I, J, K all the way to Z and yeah. I mean, that will make this problem sound very stupid, So, on Z, you have a question on Z. Okay, so here, consider the price change from 0.15 to 0.45, and households consuming this amount. Okay, so what assumption here? What assumption here is the household is not changing the amount after the price change. Is that okay?
Is this equivalent variation? Equivalence variation?
I have no idea what's that.
Because it says after the price change, right?
Yeah, you can discuss on that. I forgot that part. Exactly. And also, 250 will be the quantity you consume before, and now you still consume this So you are losing them. You are spending more money. How much you spend? I think that can be easily calculated, right? You subtract 0.45 by 0.15, and you times 250, and that's like the additional price you have to pay for the household. So the government should give you that amount to make you as happy as before. Does that make sense? The compensation, the ideal compensation is no matter how much you spend more, the government should compensate you.
Should we take into consideration 150 also here, the subsistence level?
Oh, sorry, I think that should be compensation in expenditure, not compensation in the purchasing power. That should be idea of I here. For the idea of H, let me see. Oh yeah, exactly. That's the idea here. No worries, it's the idea here because the definition of this compensation is compensation in purchasing power, CPP. The idea of compensation in purchasing power here is to make you can afford the original one, can afford the original bundle. For example, we are consuming this amount of the electricity, and no matter how much amount of the other good, because the price won't change and the amount won't change, and the only extra expenditure you are spending is on the electricity. So this difference. If the government can support you with this, you can afford the original bundle. Okay. If the government can support you with this difference, then you can still consume the original bundle. And what does that look like? So this, if we put electricity and this is insulation, this is the original price. One price is 0.15, and when we increase the price to 0.45, what will happen to this curve? To this curve, will be
extra 250.
Steeper.
Steeper, yeah.
Yeah, steeper because you see, again, I do this again, and to impress you, the Px is increasing. The Px, the electricity price is increasing. So the slope is getting bigger and more negative because we put a negative sign. Once it gets more negative, it's steeper. More negative means steeper, okay. So it goes from here to here. And that's your original bundle.
Wait.
Here is your original bundle. Let's label it A. And if this is a budget constraint 1, original budget constraint, and U1, maybe utility curve, and this is budget constraint 2, okay, I label everything. And now the government is doing a thing. He's transferring money. So which line do you want to move, as I mentioned? If the government is transferring money, giving you more incomes, which line you want to move? BC1 or BC2 or U1?
BC1? BC2?
Yeah, that's something happened after the price. Right? After the price changed, your budget constraint is this BC2. So the government is actually moving this BC2 out to make you can still afford point A. Does that make sense? To make this line out until it hits point A, so you can still afford point A. Usually, this is very strict because usually the government always want you to make you as better off as before, better off as before. But here it wants you to afford the original bundle. So if as better as before means we move this until it can be tangent to the different curve, then you can as better as before. But here, if just here you have to pass point A, so you can afford some bundle A. So we move it this way. Okay, so actually the government is transferring some money and pushing your pulling your budget constraint outward to BC3, budget constraint 3, this line.
So what are we actually writing in this?
Exactly, and here comes the question. Would you expect to remain its original consumption after compensation? If now your budget constraint is BC3 and you have U1, will you still choose point A? That's my question.
It will be the same, right?
You can stay the same, but here you can see you can choose some bundle which makes you better off.
Oh.
Does that make sense?
Exactly.
Yeah. Let's go through the process again. BC1 is the original budget constraint. The price change and you go to BC2, and then the government pull your budget constraint outward until it hits point A. And when it hits point A, it has one more intersection with the indifferent curve, original indifferent curve U1, which means you don't have to choose point A. You can choose some point here. That point maybe B. You can choose some point here. You can choose some point which has a higher utility than A. Then the answer is, then you see, would you expect the household to remain as original consumption basket? No, right? Because it will change its optimum bundle. It can choose some point on the new budget constraint BC3, which has a higher utility level than before. Yeah, I got some chopsticks, some colorful chopsticks. I can label this clear. Sorry. I forgot my left. This is U2 with BC3. And U2, here is point A, here is point B. U2 is higher than U1, and point B has a higher utility than A. So that's why you won't stay at A. You will change your your optimum bundle.
Is it that A and like utility curve 1 and 2 would like at some point intersect? Are they intersecting here or not?
You mean this utility just shift this
Yeah,
way?
because the
Yeah, I mean,
tangent.
that's how the professor draw in the answer keys of all of this. Yeah, make it intersect, you know.
So we don't know if it's intersecting or not.
I presume it's not intersecting
Because-
because if it's moving beyond A, then you could afford A, but your utility could also increase at the same time. Right? I don't know.
Let's maybe go deeper. Yeah, let's stop here. Yeah, because we still have
We'll discuss.
because we still have
Let's
two
do
more
that
questions in this question, which is very stupid. Yeah, two more questions. One is like the where is that? Oh, it's here.
We have done H.
Yeah.
I, J, K, L.
One is if not,
GTL.
right? If not, it says if not, yeah, definitely not. You are choosing B instead of A. If not, would they purchase more or less electricity? You can see A and B will that be more or less B compared to A. You got this way, right? You got this way. So this way means less electricity. So you consume less electricity.
Wait, what are we doing right now?
Yeah, it's a question number.
H last 2-3 parts.
Yeah, H last two parts. H.
Oh.
The question is, if not, would they purchase more or less electricity? And they will purchase less because P, is from the graph you can tell. Would you expect the household to be better or worse off after both the price increase and compensation? So, which means A and B. B is better off or worse off? Easy question.
Better
off. Yeah, you all got it. Great. Yeah. Okay.
Easy.
And yeah, actually the answers are like 4 to 5 sentences, but the process is quite complex, you know. The answers is better off, less electricity, and no, it won't remain as a consumption basket. But you have to draw this graph. If you don't draw this graph, you will, I won't grant you points. I mean, for these guys. For Eric, I don't know. For you, I cannot say. Maybe you can still get the point. Question I. Should I get a white? Oh, I'm running on white. You got white chocolate? Yeah.
I'm sort of
I
saturated.
feel like
now.
this
I'm
entire
already
question should be one concept.
Yeah, question I. We're almost done. Yeah. Come on. We're almost done. Question I. Compensation in expenditure. You remember this is CPP and now we have CIE. Okay, it's compensation in expenditure, which means under this scheme, if a household ends up spending $100 more, then they will be sent a check for $100. So the government. Yeah. Okay. Sure. So what's the difference between this one and this one? As here, the person does not necessarily have to choose point A. He can choose anywhere else, right? And here, the government only compensates you to the previous budget level, like to the previous budget level, but you don't. I mean, how to say? The government just give you a check. Just to give you a check instead of supporting you, granting you the money to let you choose yourself. Does that make sense? The difference between this one and this one is this one the government gives you money first, and then you choose your optimum bundle. And for this one, you choose your optimum bundle first, optimum bundle first, and then the government gives you money to make you like to compensate your extra expenditure. So you have to choose first in this situation. In this situation, you can move the budget constraint here, and then make you can decide. But here, what the graph looks like? Let's draw this, and you can see the difference. Here, it's quite the same as before, E and I, and this is the budget constraint 1, and this will be the U1, point A, and then you got BC2. Here, what the government is doing, first you choose what bundle you are consuming. You are maybe consuming this bundle, like this bundle B, I call it B again. So you are choosing B, and then the government gives you some money to make you maybe happier. But we cannot show that money on the graph. That makes sense. Yeah, because you have already all this graph. All the purpose of this graph is to solve the optimum bundle. Here you already got your optimum bundle, so you don't have to use the graph anymore. The bundle is B. Okay, and now but the difference is you get some extra money from the government. Still good, you get some money from the government. You see, consider the same household from 0.15 to 0.45. And here, since you choose your own optimum bundle first, that's why you cannot calculate as this, subtract this, and times this. You have to calculate the difference between like the two expenditure schemes. And in the first one, you are spending 0.5 times 250. And after the change, you are spending 0.45 times 150. And you subtract, you find the difference between these two numbers, and that's what the government should give you. Did you get that point here? No. Yeah, because, sure, I'll explain that again.
Consider the same amount.
Yeah, here we are still assuming like the quantity of electricity after compensation is 250.
Okay.
Why is that? Because the government wants you to afford that. But here you already consumed 150. That's the difference. You already consumed. So what the government should give you can be based on this condition. Can be based on how much you have spent. Like you can calculate your expenditure first, and the government then decide how much to give you. Like you do your own decisions first, and then we compensate you. Instead of a promise like this, you can see this plan is definitely better because it's like a promise. Just buy something. We will afford you until you can afford like you can still afford like the original bundle. But here it's like just consume, and we will see how much you expend more, and we will consume that part. If you consume less, if you consume less than before, the government won't give you any money because you are spending less money than before. But here always a compensation. There's always a compensation. So CPP, there's always a compensation. Since the government wants you to be, it's a promise. But here it's just the government is like watch you first and then decide whether to give you the money or not. That's the difference. And if you calculate, there should be a difference. You can do the calculation here and let me do it.
It equals 75. The difference is 75.
This one is greater or smaller or bigger?
It's bigger.
It's bigger. So this one is 75, which means...
No, that one's 112.5.
112.
Wait, you talking like when you subtract them or?
After subtracting, we get 75.
Yeah.
I see. Okay. Okay. So which means after once the government raise the electricity price, I said this way. You can maybe write that down. That would be the right answer, I think. So after the government has increased the price, this household is spending $75 more on his household expenditure for warm, to get warm, and then the government will compensate him this amount. Yeah, that's like the process. First, second, and third.
So they would only compensate if they end up spending more than $100, which they are not. So the government won't compensate them. Right?
No. There's no such limit. It's just an example for the 100. They will still compensate. The 100 here is just an example. It's not.
Oh.
Oh, sorry, it's not like a limit. It's not a limit. It's how much you spend more. I will compensate you.
And then, so, like, in that example, are they better or worse off?
Are they better or worse off?
Yeah, worse off.
Yeah, worse off.
Yeah.
And
Lower utility.
yeah, actually, because this plan is better, and the answer here is what if we assuming like a household receive no transfer, right? If a household receive no transfer, in this one the household will always receive transfer, but in this one a household is possible to receive no transfer, right? For this, if this number, I mean, if we set this number to 100, then it's receiving like maybe not 100 to 10. Right? Then this household will receive no transfer, and this household is definitely worse off. And you can generalize this household to all the household. All the household are worse off from this C in E plan, like CIE plan, and CPP plan is definitely better.
That makes sense. Appreciate it.
And yeah, last two more questions actually. J3.
Yeah.
Oh,
You can just do it.
oh, okay. 3. Okay, J. A first. Consider two households, A and B, that consume the same amount of electricity before the price increase. Electricity makes up a large share of total household budget. You see here comes the electricity. For one household, electricity makes up a larger share, and for the other, it's not. What can you infer about the household income relative to household B? So if they consume, this one, I mean, this question, I don't know why even you have to answer. For this question, A and B, if A consume 250, B consume 250, and for A is a large share, will A's income bigger or smaller than B?
What do you mean by a large?
I mean a larger share, which means this is maybe 100% of its income, and this is only 10% of its income.
Oh.
Does that make sense?
Yeah.
100% and 10%, which means the income for A will be 250, and the
Yeah.
income for B will be 2,500.
Yeah.
So A has a smaller income.
Oh.
Yeah, because the share, the share, the share. Yeah. I like to share something on the share. I was in an interview yesterday, and there's a interesting. It's an Excel exam. I ask you to. This is the column for 2009 GDP for each country. Country A, country B, China or something, and it asks me to use a formula to calculate the GDP in share. To fill in this shell, this column is called GDP in share. GDP in share, and you have to fill a number here. So what do you want to fill?
GDP in share. Is it the percentage of a country's GDP over?
But you only got this line.
Wait, what does that represent though?
This is the GDP. It's a 2009 GDP. The numbers for all the countries. So what do you want to fill like in this cell for the A? What's the GDP in share? It only has a column. It doesn't have any other hints.
What's the GDP in share?
Yeah. So I was stuck on this question for about like 5 minutes and waste a lot of time, and then I asked someone for help, and he told me the GDP in share is A's GDP in total share.
Oh.
You just add them up. You sum them here. You sum a total number here,
Okay.
and you divide this by
Yeah.
divide A by this total number. You got the A's share. Yeah. If someday you got this exam, send me please.
What exam is this?
Some interview exam.
Oh wow.
Like
Excel exam. So you also have to know the function, like the sum function, like the sum functions. Yeah, you will learn.
Excel is a very powerful tool. Like you can do regression in it.
Okay.
Yeah, in Excel.
So here, if we assume A has a larger share and the electricity has a larger share, A's income is higher or lower again? Like 100%, 10%, can you tell? Yeah, you just write this down. If the first sentence for this answer should be, if A's electricity in the income, the share is greater. If the share is greater, A's income is lower. Okay, A's income is lower. So then you got this A is smaller than B. If we use this to indicate that A is smaller, like the A's income is smaller than B. Then the next question will A or B be more elastic? Which one is more elastic?
A.
A is more elastic. A has low income. So
This is why.
yeah, if the
Oh no, inelastic. B. Well,
Inelastic.
A will be more inelastic.
yeah, A will be more inelastic.
Yeah.
B will be more elastic because when you are richer, you are always more elastic. You can afford something else. You are happy to change. Okay. Think of maybe a car, like a car. If the price of a car is increasing by 10%,
Yeah.
for a household with this, will he afford that car? Will he? I mean, oh no, sorry, this is not a good example. I'm trying to read
It's
this.
like, for instance, can you afford the oil for the car? So if you're a rich,
The maintenance of the car.
Yeah,
let's say.
something like
so
that.
if you own a BMW probably or an Audi, and can you then afford the maintenance of that car? Because
Ah,
you have
yeah.
got like bigger. Yeah.
Exactly, like the maintenance for the car. So if you have more like the money, you can afford something. You can afford more, which means your budget is more elastic. You can switch the components of the things in your budget when you are richer. You will have more money. And so then let's write this down. Electricity of A. If A is smaller than B, A's income is smaller than B. Electricity of A is smaller than electricity of B. Here is not like the electricity is not a number. It just means A is more inelastic. Okay, A is more
inelastic.
inelastic. I write this down. Inelastic. I think the professor gives you some good points on how to write like the inelastic and elastic. So
I
you can,
and the E.
like the I don't know. This is elastic, right?
Yeah.
That's good. So A is more inelastic. Then what's the question?
Which household will receive a larger amount of compensation? Right? Is that-
Large amount of compensation. Okay, sure. If A is more inelastic, so A still spend that amount.
So then B would get more compensation, right? Because they'll be spending more.
Well, no, but they are spending the same amount, though. Right?
No, but if somebody is willing to spend more, they'll get more money in return.
Oh.
Electricity more elastic in household that's income.
No, but they're spending it says they're
Oh, sorry.
the same amount.
I think I got it. Actually, here should be like this way. Yeah. But that's economics, you know. You can always go one way or the other.
What happens?
Yeah, what happens? You can always. Here answer key terms. It's like should be this way. Elastic. I mean, A like if A has lower income, then in this situation for the consumption in electricity, A is more elastic, because when the price change a little bit, B is very rich. You think of the head of B is very rich, so he said we can afford it. We still consume like we still buy this much of the electricity. A maybe change his plan. He changed his plan. Yeah.
So
Question.
does that mean that B is compensated more?
Yeah, exactly. So B is compensated more.
And why is that again? Like, could you explain it in a way that doesn't rely on elasticity?
Yeah, sure. So for the elasticity here, since A got lower income, and when the price change, A cannot afford that part, so A changed his budget, which means the quantity reduced. The price change a little, the quantity reduced by a lot. Is elastic,
Okay.
right? And for B is okay with like the fluctuation of the price. B is very rich, so he can afford. And B is okay, so when the price change a little, the quantity doesn't change, which means it's inelastic. So B is inelastic. So for the party which is inelastic, this party is inelastic, and after the price change, he will still consume a lot.
Yeah.
But he will still consume a lot, so he has to bear the price change. He bears the price change a lot, and like the price burden caused by the price change, and then the government has to compensate B a lot. Does that make sense? So B, let's give like directly examples. For if before 250 for both, and after the compensation, B still consume 250, and the price is this, right? And A consume like 0, and price is this. So A is spending like this money on the electricity, and the government won't compensate A at all, since this is before he's spending some money, but now he's spending barely 0. So the government won't compensate A, but government will compensate B because B is spending more money. As a plan, the plan says if you spend more money on electricity, we will compensate you. So for the inelastic party, the government will compensate, and that's very inconsistent with our. That's very aligned with our. Remember on PS2, the inelastic party always takes more, right? The inelastic party bears more burden, but also takes more from the compensation. So inelastic party gets more, but also pay more in tax. Gets more from compensation. Inelastic party gets more from the compensation. So B, but here B is inelastic. As the price change a little, the B didn't change his budget, didn't change his plan of buying like this on that. But A will change. A is very poor, ending poverty. Yeah, that's a mission for the World Bank. Okay. So that's the answer to J and K. Compare the compensation approach to the tiered pricing approach. Does the compensation approach face the same trade-off between generosity and the efficiency? Oh yeah, that's the one I didn't get. Okay. Yeah, I don't.
We can wait for the video.
Remember. Yeah. Regardless of the amount of compensation, customers will be making their choices based on the price of something. Yeah, here I think it's like the compensation approach. I can see it, the compensation approach and to the tiered pricing approach. Or PPA. Like the compensation approach does not face the trade-off. This one does not face the trade-off. No trade-off. And why is that? Because the consumer still choose like always making their choices based on the price that accurately reflect underlying costs.
What?
Yes. Did you remember like the definition of TE, the technically efficiency? It's like if you consume when your price reflects the cost, right? When the price reflects the cost, that's a core for the TE. If the price reflects cost, in this plan, in the compensation approach, the price always reflects the cost. Why I don't know. That's why I can tell you I don't know. But the price you can try to do something by yourself.
I will wait for your video probably.
But for this part, but the price under this approach can definitely reflect your cost. Why is that? Yeah, talk to professor maybe. Yeah. Okay, let's leave this question. That's the answer. Because this one does not face a trade-off. Because this one the consumer will always choose like the TE, so there's no trade-off. They will always, there's no trade-off between the generosity and the efficiency, which means you increase your generosity, you have to lose some efficiency. But here you always follow this, so you will not lose like the efficiency, because the consumer always make choices following this. And why? Yeah, that's the part you may have to. I don't know. Yeah, I don't know.
We're gonna write this today.
Yeah, I will tell Eric to be generous. Try to be generous on this. It's a generosity questions.
That was a good one.
Yeah, the last one. I. Oh, it's L. Oh, yeah. It's L.
No, J. Okay.
Suppose the government were able to fully and fairly compensate all households after raising price through cost recovery. Suppose the government can't fully compensate, and the amount of money required to do so ate up all the additional revenue. Means you see, the government increase the price, there will be revenue, right? There will be extra revenue for the government, as the electricity is a state-owned industry. It's like the revenue gained by this is owned by goes to the government. So the government increase price, it will increase the revenue if raised. And however, when you like compensate, you are giving out compensation. And which means the government is expenditure. It's expending the money. Also goes up. So if this part and this part equals, which means all the expenditure ate up consume all. Yeah, ate up is a good word. Ate up the revenues. What will happen? Will the government still still try to raise the price and compensate, or just maybe not raise the price?
Think about it.
Yeah, what's your intuition? Should they do this? A or B? A is nothing. B is raise price and compensate. Will be A or B the government?
No.
I think A. No.
Not
B. B. Yeah. So what's your intuition tells you? For A, what's that? Why is that? Maybe doing nothing is, yeah.
Wait, no. Wait, I was confused. What was B again? B was raising prices.
Raising prices and giving out compensations.
But when they do A, because you want to limit government expenditure.
You want to limit that government expenditure.
Yeah. So you don't want to compensate people, right?
You don't want
and in order not to compensate people.
Doing nothing means does not raise the price. Yeah, the price is still the same.
Oh, okay.
Let's do it at all. Doing nothing at all.
Yeah.
Then doing nothing probably.
Doing nothing at all.
Yeah.
Not raising because then maybe the transaction cost, right?
Yeah.
Yeah. That's what my intuition. But from the answer key, I think he's expecting answer B.
Oh.
Yeah. He's
okay.
Yeah. Why is that? Because if we're doing nothing means you don't change people's behavior, and they are still consuming inefficiently. Remember to the first question.
Okay.
What's the problem with this industry? Is people are consuming extra inefficiently.
If there is an increase in price later on, then it becomes easy to handle the shock for the people because they're already paying a higher price for it.
Yeah, they're already paying.
Yeah, because so if they increase it,
if you do not want to compensate, but people, they will. That might be a.
They can always alter the compensation structure, and then people will get used to it eventually.
Yeah, but actually that part is also makes. Your point, the transaction cost, and why we do so many things, but we're still raising no revenue. We're still not getting profit from this, and that's just a waste of time and money, especially the people, like the management and the efforts. So I think you can stay both, but play safe. I suggest you to say B, to just try to do this, because in question A you answer that it's inefficient, and now you can change the inefficiency, which I had it out.
Okay. Can you just tell me this answer, 4.18, the answer?
Which one?
This one. What is the answer for this?
4.18, right? 4.18. The answer is exactly well off as a 60. You got 60?
So 60 was the initial redeemable only.
30?
30, right? Yeah.
Okay. Should be 30. Yeah. Actually, yeah. I will send you some links about the answers to this, but not the answer key. So maybe I'm not sharing the answer key. I'm just sending you some links. So
okay.
Yeah, keep that a secret, please. For the textbook questions. Textbook questions. Answers is really everywhere online. But yeah.
I might be. If I have doubts, I'll be mailing you basically.
Sure. Okay.
That's
Okay.
fine.